involves, so yeah, one more thing to add here. The instruction page has a checklist, which is right over here, right? So this checklist can help you or guide you through the entire task on what to do. So once I have explained the entire task, and when you come and look at this checklist, it would make more sense. So once I've explained the task, I'll come back to this checklist and we can go through it one by one. So, okay. This section over here is, you write a small statement to the reviewers, basically the person who will be reviewing your task. So you would essentially make a small statement stating what your problem or what you're trying to target here in this task, so that when the reviewer looks at your task, they understand what they are trying or what they are getting into without, going through the entire thing and, wasting their time. So this small paragraph over here would be nice so that reviewers understand what they're getting into before, you know, submitting or before getting into the entire task. So I would just be like, this is a sample context for the.
Yeah, just to be clear, the since this is a task where you submit the task and then you'll run through all the checks, which we'll go through what happens on GitHub. Once you go through all those checks, once you do, like if all those checks pass, there's a very high chance that you will like have that task be approved, which means that we just want like to make the review time fast. You can be like, hey, these are the verifiers and this is what we're checking. I don't know what kind of context you want to provide. It's a box that allows you to just tell reviewers how to quickly check your task to make sure that it's perfect so that that means the more number of tasks you get approved, the sooner the more money that you guys make per each attempt. So that's why we have it set up so you can give some feedback or some notes to the reviewer. Got it?
Yep. Yep. So over here in this step, currently, actually, you get a link to the repo, right? So the moment you enter a task, you'll get a invitation over your email that would contain an accept invitation for the repo that you're going to work with in the task, which would come after the proposal part. So, for example, I've already accepted the invitation. So let's say this is the repo, right? So this is where the main task starts essentially, right? So what you would do is you have commands over here. You would first fork the repo, right? You work on it, and then you essentially push it back to the main via PR, right? So the first part
Good.
is you fork. Yeah.
Good. Just I want to be clear, like for the first job, the first thing is to fork, then you work on it
Yep.
locally, which requires you to have Docker as well as Harbor installed locally. These instructions will tell you how to do this step by step, but the goal is you can commit as many times as you want to your like forked like repo, and then once you are ready to submit, that's when you open a pull request.
Yep. Once you are confident about the task and it has passed all the hardware checks, that's when you
Yeah.
go and raise a PR for this task.
Yes.
So
So let's explain that.
the
So like you fork it and then scroll down a little bit. So you'll fork it, you work on the keep going down, keep going. Yep. So this is where you install the Harbor, and then when you run your task, what it is there's an Oracle. The Oracle is something that comes with this thing called Harbor, which is just a framework that's being used to like make these tasks a little bit more standardized and easier to test. So you'll run this Harbor check locally, and that will help you determine whether, hey, like it checks a few things. It checks that it checks your verifiers against your actual run code and see that the reward is correct. It also checks that it's in the correct format, I believe. And the last thing is there's
Yep.
also another one for no op that happens, which is
Yeah.
not here.
Yeah, so
Yep.
essentially the idea is this is using your golden solution that you created. So that's what the Oracle thing does. So in an ideal world, your reward text should basically equate to one. that gives
Yep.
us a proof that your solution is actually good and solvable and it's verifiable.
Yep. Always, the reward should always be one for the Oracle solution. It should pass all your test cases. That's when it comes to be a one.
Yep. Sorry, yeah, I think that that was a little bit confusing. Does anyone have questions about this?
Yeah.
I want to make sure this is super clear because this is how you actually
Y-
do the task on GitHub.
Yeah, I think like explaining the task in the VS Code should make it more clear.
Questions? Everyone understand how to work on a task and how to make sure that it's good before opening a pull request? Has everyone here worked with GitHub? Might be a stupid question, but make sure everyone is
Understand.
aligned.
So,
If you guys have any questions about GitHub and how to like, use all this interface, I know some people aren't it's not always very clear. So, but good. Okay. All right. Please ask any
yep.
questions because there's no such thing as a stupid question. We just like we already know you guys are really good at what you do. So, we just want to make sure it's clear. Cool. All right.
Who is GitHub? Right. Who is GitHub?
My friend GitHub.
So,
I only
yeah,
know
my friend
Bitbucket.
GitHub.
I only use Bitbucket. I don't know what this is.
I mean,
All right.
I only know local storage, right? So the first thing you would ideally do is you would fork the repo, right? So the repo, you get the name from here, and yep. So once the repo is forked and cloned into your system, we'll just go through each of these folders that you were here that exists over here, right? So we'll just go through each of these folders that you were here that exists over here, right? So every task is essentially like like four contracts that have to agree with each other. So the four contracts here are environment, solution, test, and instructions.md. So the main part or the starting part of your entire task would start with instructions.md. So what instruction.md essentially is that it's like a prompt that you are providing to the model. Over here, you describe everything related to the problem that you're trying to make, every single file um, that you're trying to reference. And at the end, you just describe this one line that you have 120 seconds to complete the task. So I'll show you an ideal instruction as well. And the next part is instruction.md is just a prompt. Okay. And the next part is environment. Environment is basically where the model builds its Docker from, like the initial starting point of the model. So when Harbor is run, the model enters to the task using the environment's Docker file. It runs this Docker, it creates its own container, and that's where it runs the instruction.md. Right? That's where it runs your prompt. So the prompt is given to the model inside the environment, right? And solution essentially would contain your final solution or your golden solution that you are trying to make. So this solve.sh does nothing but run your solution. So here over here in solution, you would also make a file called solve.py, right, which would have your actual solution. And then that solve.py is run using solution.sh because Harbor accepts solve.sh as its format. I think we have some questions. Yep. Okay. And the last part is the test cases. The test cases over here has a separate Docker file as well because terminal bench 3 tasks run the verifiers separately. So in our context for terminal bench 3, we also call test cases as verifiers. So the verifiers run separately in their own Docker environment where you would put your test cases in test outputs.py, and the test.sh essentially runs the test output.py. And it all runs in a separate Docker container so that the agent that is running on this the first Docker container doesn't cheat by looking at the test cases over here. So any questions till here, or does anyone has any doubts? I'm hoping no one has any doubts.
Yeah, not seeing any.
Yep. I'm assuming that people are understanding, and if you are understanding, I mean that's really great. Then yeah, yeah. So, just a side note for the instructions part. Some of the rules that I follow for instructions is, like since this is the most important file and it should be with respect to the way terminal bench tasks are structured. So, what I usually follow is that I always give absolute paths to the model. Right. So when you actually clone this repo, you'll see some instructions already written over here. And any output file that you would want the model to produce, you also have to give the absolute path and you name it specifically that I want the output file to be named xyz.csv and stuff like that. So that is very important. And when you actually structure a prompt, right, you basically make sure that you describe the model what to achieve and not how to achieve. You're not essentially giving the model the solution or steps on how to get to a solution, but you have to just describe what the model is supposed to come up with, right? The entire thinking part, the entire logic part is supposed to be done by the model. And like, for example, you can't tell the model, use this XYZ library to do this. That's like giving the model the solution. The model itself has to figure out that, okay, Pandas library has to be used for, let's say, data processing or data manipulation and stuff like that. And whenever you're trying to describe outputs, right? Like if you want the model to output something and you try to describe that inside the prompt, you make sure that you describe it using the file format you want it in. Like I want abc.json as my output format. I want xyz.csv as my output format, right? And the last part is that yeah, this line, we just make sure that, we give this line as a placeholder for any kind of prompt that we are trying to make so that, it just stays with the model. Any doubts over here or anything uh, with the instruction part on how to make the instructions, what goes inside the environment folder, what goes inside solution?
Yeah, okay, just that final line with the you have 120 seconds. Is there any guidance for when we should be changing that number to something else, or it should just be 120?
No, I usually we try to keep it at around 900 seconds or like 600 seconds.
Okay,
Yeah, like 600 to 900 is what we keep it as standard. Here it is just 120 as an example, but
okay,
we try to keep it like 600 to 900 so that it gives the model enough time to make a solution. Because what happens in this modern LLMs is that they start reiterating their own solution,
right,
right? So it wouldn't be a benchmark then. It would just become something that the model is just trying to finish.
got it. Okay, so basically then like so how is there like a way of determining what number to use there though, like, or do we
It
just
depends on the Yeah, it kind of depends on the difficulty of the task. Let's say you determine that the task that you're trying to make is like very, very long. The solution is actually very difficult. You can probably keep it at around 900. And if you think that it's of a medium difficulty, then you can keep it at around 600. That's what we actually follow. At least that's what I follow.
okay. Okay, cool. Good to know. Yeah, I mean, so just and this is assuming it's like a when you say the model, you mean it's like a coding agent, right? Like
Yep,
something like
yep,
Cloud Code. Okay, cool.
yep. It would either be so okay. So for everyone's context over here, we'll probably be trying to your whole point of this entire project is trying to fail a state-of-the-art model, right? That is available in the market. So a SOTA model would ideally, in our scenario or in our current meta, would be Opus 4.8 or GPT 5.4 or 5.5. Like you ideally try to make a task that you think would fail these models, right? So yeah, just keep it that in mind when you're trying to like design some tasks. I hope that's like clear now.
Are failures just like the solution that it creates is poor or
Yep.
incorrect, or is it that it doesn't do it in the amount of time too?
Yeah, if it doesn't do it in the amount of time, what would essentially happen is that it would be like an incomplete solution, right? So that is also that is also counted as a failure.
Okay.
So the main failure for this entire project is that the test cases. So you would make a test suite that would cover the entire coverage of your prompt. So whatever your prompt describes or whatever prompt describes to do with the agent, you would create test cases based on that, right? And your golden solution would ideally pass all these test cases. So what we expect the model to do is that the model is given instructions, very precise instructions, and the model would essentially make a solution that would be run against the test cases. So let's say even if it fails like one test case or two test cases, which are like important, that would essentially mean that the agent has failed. So
Okay.
that would count as a failure. Great. Any doubts on how you would what the environment is? Okay, one more thing. So when you're making a task, right? So the environment is, as I said, this is a starting point for the agent. So inside the environment, you could also include the files that the model would use. Let's say that you're making a prompt for something related to data manipulation or something related to data cleaning and stuff like that. This is very basic as an example, but like what you would essentially do is that you would also give the CSV files or the JSON files or whatever data that you're trying to clean inside this environment as well. Let's say there is some CSV file that you want the model to clean. So you in the instructions you would describe, hey, I have this CSV file and I want you to clean the CSV file, remove duplicates, etc., etc., and put this output file inside the put the cleaned output file inside some folder, which would be inside the Docker folder, right? So over here, when you do that, you'd also give the CSV file inside the environment. I hope that's clear. The
Right.
environment essentially,
Any
yeah,
any inputs you're saying should go inside that
yep,
folder,
yep,
right? Don't,
yeah, any
and
inputs, yep.
and should we like assume that like no, there's no network access, like it shouldn't rely
It does
on.
have,
Oh, it does have network access. Okay.
yeah. So if you notice the task.toml, the network mode is usually public.
Okay, cool.
So it does have, yeah. Right. Any doubts, at least for these four parts? Okay. I hope it's good. Then just and like for the solution part, moving on to the solution part, solution is basically how we sanity check the whole thing. So this is in Harvard terms or in this project terms, we usually call it an Oracle solution. So it is the Oracle solution is nothing but it's essentially the answer key with the perfect solution that would pass each and every single requirement of your prompt, pass each and every single test cases that you would make. So that's the solution. The last part of this file structure is task.toml. Task.toml is nothing but it's a configuration that goes to the model and or a metadata, right, for this task. So this is like semi-important in the task because there's a few things. So the timeout over here, these timeouts are the same timeouts that we had set inside the prompt over here, this timeout, the 120 seconds that we set here, you would essentially set it here as well because this is where the harbor takes it from. Okay. Sorry. And this basic build timeout is for the Docker, right? The Docker build should not exceed more than 600 seconds. So since there are like a three-step process here, first the image gets built, and then the agent runs, and then the test cases is verified. So this is like the three-step process here in Terminal Bench. So each of these process has their own timeouts given. Since all three of them are essentially, running inside a container and the test cases are running in a different Docker itself. So the verifier is a test cases. So the test cases shouldn't exceed more than 120 seconds. the agent's run shouldn't exceed more than 120 seconds according to the prompt. So let's say your prompt has 600 seconds, so this would change to 600. And the environment mode separate is nothing but the test cases and the environment. These both would run separately so that there is no cheating from the model side. And this would define the resources that you want to allocate to the Docker if you're running it locally. Is there any doubts with the metadata of this task? And the rest are all, self-explanatory. You could just keep your name, the author email, and the organization, difficulty explanation, solution explanation. These are all like normal explanations that you would keep over here. And what kind of what kind of category does this belong? Let's say machine learning, deep data engineering, or it could be cloud infrastructure, anything. These are all just normal metadata tags. These are the main configurations that you would see down over here. This. So I'm hoping everything is clear from your right. Instructions, right? Okay. So I'll just paste some of the rules that I use for instructions so that it's more clear. Just give me a second. I'm going to be pasting what I use for the instructions myself. Right. As I started off, so the instructions is the starting state of the model. We could go through the lovable as well. Yep. So the instructions is by default the only thing that like the agent sees when it actually starts the task. So after the model has entered inside the Harper's container or the Docker container of the task, so the only thing it gets provided is like the instruction.md, right? So you could just consider it to be a normal prompt. Let's say I'm assuming all of you guys have used Claude Code. So what happens is that when you are trying to prompt the Claude Code, you would only provide the prompt, right? So that's all even the model gets. The only context that it gets is what is inside this environment folder, like whatever inputs that you give inside this environment folder and the instruction.md. So that is how you would usually use even Claude Code, right? So you give it enough context on what is there in what you're trying to do with certain folders or your input and what you want to get or what you want to achieve. So the way I see it, right? So when you're writing instructions, you write it in such a way that you describe what you want from the model, right? You describe what you want. You don't describe how you want it to be. The thinking part, the logical part, entire solution construction, everything is supposed to be, like done by the model itself. You don't say the model how to do it. You just say the model, okay, I'll give you an example. Let's say in the prompt, you just go like, I want to add two numbers. Give me a function for it, right? You don't tell, use the plus operator so that I can make sure I can add those two numbers. But I instead just say, make me a function that can add two numbers. I have given the model my problem statement. I have given what I want or what I'm expecting from the model. That's like the first rule of making instructions. The way you design the instruction or way you phrase your instructions is that you describe the model what you want, not how you want it. Right? That's the model's part, or that's the model's headache to figure out. The next thing is that when I'm trying to describe inputs, right? I make sure that I describe it accurately. Like, so what happens is that when you go into the Docker file, your working directory is usually the app. So when you make a Docker file, what you would essentially do is that you would make it in such a way that you copy even the input files. I'll just show you an example. Actually, with the example, it would be like much easier to understand. Yeah. So, okay, I don't have any input folders over here, but yeah. So over here, when you, let's say there were some input files inside this environment inside this Docker file. So what you would do is you would also mention some CP commands here to copy those input files inside the environment. So when you do that, you mention the same thing inside the prompt as well, right? You mentioned the same thing over here in the instruction.md. You would state that my input files lives with inside slash app slash xyz.csv. This is my input file. So you have to make sure whenever you make a prompt, you explicitly state where your input files are coming from. That's the second most important step. So the first most important step is you describe what to achieve. The second most important step is where your input files live with their explicit path to that input files, right? The third main part is once you have described what you want and the input files, the third is how you want the output to be, right? Like what you want the model to output to you. Let's say you want a file to be outputted. So when you say you want a file to be outputted, you have to explicitly state even the path for that. Like let's say I want the output to be in app slash output slash some xyz dot csv. I want the output to be in this format. So that's the third step you would actually uh, do. Okay, we have a question. Does app resolve to environment or is app just an example folder to structure the environment? Okay, so app is just a working directory inside the Docker where the agent would essentially start. So the same way, let's say you have a working environment. Let's say you make a directory over here and you start a project, right? So this is that working environment or the working directory for us. So app is essentially just where the model would start. You would just copy all your folders from environment and the instruction.md to the app. The instruction.md does not need to be copied. It's only the input files inside the environment that needs to be copied over here. I hope that clears your question, Eric.
Well, I guess I was asking is so you would create an app folder underneath of environment?
No, no. You create the app folder inside the Docker folder. Docker.
Got it, got it, got it, got it.
Yep. So I'm hoping is the instructions part clear. So it's just like 2, 3 rules, and you just like expand on it. Like first thing you describe the model, what you want. Second thing you describe the input files. Third you describe the output structure you want the model to output, and it's mostly it. And then it's just problem statement that you provide to model in form of a very long and detailed prompt, right? So for example, a prompt would look something like this. So this is an example prompt from one of the tasks from terminal bench itself. So if you notice that, you would notice that this is very, very detailed. And over here, it's just asking, like saying design 2D silicon for that demultiplexes, etc., etc. And then there's no answer over here, right? There's just like giving an idea on how the user wants the model to output, or how the user wants the model to proceed to this problem. It doesn't describe how it wants to like continue, right? And then it also says write the output folder, write to this folder. Since there is no input folders available over here, that's why there's no input folders mentioned. Plus, this is the output. You can also describe the way the output folder is supposed to look like. So meta.json he has described that it wants it to look like something like this. You can describe as much as you want inside this prompt, right? And based on the difficulty at the end, you can just set this timer. Right, so this person has determined that 18,000 seconds is what is required to complete this task. So you could basically just describe that.
But
Any
at any
doubts
point, I
over
mean,
here?
you're
Yeah.
trying to, I mean, it's a tough thing because, like you said, that if it doesn't do it within that time period, that it fails. But we're trying to make it fail. I could put it down for 1 second. Like, how do you, like, how do
I
you,
mean, no,
Yeah, that's an
that's
interesting
a
question.
fair
And
point. Yeah.
speaking of model failure, by the way, like, do we need to like run this against a state of the art model ourselves and make sure that the coding agent is not able to complete it, or we just or that's kind of taken care of in the proposal stage?
Yeah,
Yes.
I can answer that
Okay, yeah.
actually.
Sure, Ritesh.
So the main idea is you don't want the model to fail because of timeouts. That
Okay.
is not a good task.
No. Yep.
Um, and yes, Sam, to your answer, that does happen during the quality checks. Um, so you will actually see a result after running some of the pass acts. So I know on some of the previous projects that you had worked on, you had no visibility to what was happening at the pass at stage. So here we are trying to set up a system where you will see the pass at runs in your GitHub PR comments. And that should basically give you a good signal on whether this is actually stumping the model. And then there should be some sort of feedback that does come in there, which should help you go edit the task if you need to.
Okay, cool. Great. Perfect.
Yep. So that's how it is gonna be. So any doubts in instructions, or you guys want to just go through this instruction once, or you can take like 2-3 minutes and understand how this instruction is being constructed. I'll give you guys like 2 minutes and you can just go through it. It's clear. Is are everyone done with reading the instruction as well? Like whatever is here on the screen. I'm hoping that part is clear as well. Great. Okay. So once everything is done, once the instructions is made, the environments folder is made, the Docker file is made for inside the environment. The next part would ideally come to your solution and test cases, right? I'll just clear that as well while I'm at it. So solution and test cases. So let's say, for example, in this task, we have a solve.py, right? So this is the solution for the instruction. So the Oracle solution, the way it is written is that we expect that the Oracle solution has or covers the entirety of the prompt, right? The coverage of the Oracle solution, let's say you're asking something in the prompt, you have to make sure that the Oracle solution completely covers it. That's when it makes it as a golden solution, right? So golden solution is like a perfect solution for the problem or for the prompt that you have made. So you would ideally package it in a solve.py, right? It would be like a Python file, and then that Python file is essentially referenced by solve.sh, right? It's nothing but a bash command that runs this Python file. Since Harbor sees solve.sh as its main runner, so that's why you need to package it in solve.sh, right? And the test cases also goes almost the same way. So you would make a test case fold file, which would essentially be a Python file with all the test cases that you think is required. So these test cases are there are some rules for the test cases as well that I'll paste in the chat right now. There are three properties when we write test cases, right? Will there be Slack for forms? Oh yeah, there'll be Slack for forms. Yeah. So these are the three requirements when we write test cases, right? So we make sure that the test cases are functional. It is not like going and checking for non-deterministic things. So when I say it should be deterministic, it should always have one single answer, right? So whenever it runs, it should always run with one single answer. So it's not like 2 plus 3. Let's say there's an example, 2 plus 3 shouldn't always give like it should always give 5. It shouldn't give like 6, 8, 10. That's wrong, right? And then all the test cases should trace back to the prompt. So your prompt and your test cases go hand in hand. So whatever requirements you put inside the prompt should always be present as a test case over here. Let's say you're trying to achieve something in the prompt, its test case, corresponding test case should exist over here. It should be a one-to-one connection between the test cases and the prompt. Is this part clear? The how to make test cases and how do you define test cases? There should always be a very good amount of coverage inside the test cases, essentially. And to run these test cases, there is a shell file that you would use, right? And this shell file essentially writes to this folder. Let's say if all of your test cases pass, you would write it. It would write it as one, else it would write it as zero. So I'm hoping this much is clear. Does anyone have any doubts over here for the test case part? Great. I think everyone is clear with this. Right. So after this entire task, after the entire task gets and builds inside your file, uh, what you would do next is verify if your golden solution would pass the test case. And just for the context, this is one of the most important part of this entire project, where you verify if the test cases or if the Oracle solution is passing with all your test cases, right? Then if it isn't, then it wouldn't be a golden solution. You would have to tweak it. So the command that we essentially use to run this is, let's say, this is the command. You always have to, the command is also linked inside the document, the instruction document. So I'll just run a sample, task for you. So this command essentially, A stands for agent over here, by the way, and P stands for the path. So harbor is the agent harness that we discussed at the beginning, and this would essentially be the path of your task. And Oracle is nothing but it would essentially run these two files, right? So when you run this is how it would look, running trials and then starting the environment, etc. So it would take like a bit of time to run. So after this run, I'll explain you how the output is supposed to look like. So you can confirm that the golden solution is, like indeed passing 100% of the test cases. I think it will take about a minute. Yep, great. So, what this output essentially tells us that it ran one trial, right? And when your mean and your reward, this should always be one. So when it is one, this means that it passed 100% of the test cases, right? So when it does this, that means that your task, whatever task that you have made, passes, your golden solution passes all of the test cases. And you can come down to this, oh, not this, sorry. I think it's over here. Just a minute. Yeah. You can come down here to a folder. When you run locally, it would essentially create a folder called jobs. And you can come here and open this folder. You can open this folder, verifier, and you can see test.std.out. Here you can check what test cases, if all the test cases passed or not. This would essentially just show you if all the test cases passed or not. And the reward.json would be this reward text, right? So this command is very, very important after you finish a task. So you always run this and make sure that it always comes to one before you submit and raise a PR. Is this much clear? I'm hoping this is clear. Yep, great. I think I see one, two, three thumbs ups. Right. Yeah. You can come down here to a folder. When you run locally, it would essentially create a folder called jobs, and you can come here and open this folder. You can open this folder, verifier, and you can see test.std.out. Here you can check what test cases, if all the test cases passed or not. This would essentially just show you if all the test cases passed or not, and the reward.json would be the reward, this reward text, right? So this command is very, very important after you finish a task. So you always run this and make sure that it always comes to one before you submit and raise a PR. Is this much clear? I'm hoping this is clear. Yep, great. I think I see one, two, three thumbs ups. Right, great. Okay, so now after you're done with the task, you would essentially use these commands. Where are the these commands to raise the PR, right? So you would git add this command does this nothing this command nothing oh my god, this command does nothing but whatever files that you have inside what are not staged, right, it just stages them to get committed to the repo, and you just add a commit message, maybe task submission or etc, whatever you want, and then this pushes it to a branch, and this is used to create a PR. So once you can either use this command over here, or when you write push, what would happen is that you would see a message here on the top that says compare and pull request. You can just select that compare and pull request, and it would create a pull request. It would create a PR that looks something like this. So once the PR is created, yeah. Once a PR is created, we have some static checks that would happen, and these are all the static checks that would happen. So there are some GitHub actions that would run on the PR to make sure that the kind of task that you're submitting is of high quality, and it's according to the structure of the project. Right, there are some evals that would run to check if like the difficulty is fine, if it is solvable, it's not unambiguous, etc. There are a lot of evals and stuff that you would see over here. It would take some time to run. Maybe it takes about 10 to 15 to 20 to 15 minutes, and after it runs, and then you'd have something called passat at the end, where you can take the screenshot of that passat. It is just model runs whatever we are discussing, the agent runs, and the screenshot of that can be attached directly over here inside the task. Please attach a screenshot of passat result you see on Git Actions. You can just like upload the file whatever you see, and then like maybe just submit it. Some file upload is required. I'll just randomly just select some file. Let's see some random file. I mean, it is not password, but yeah. Right. After this is done and everything is verified and this feedback is verified and stuff, you will be able to submit a task. So this is all about Project Dynamo. And do we have any doubts? Please shoot your doubts. And Ritesh, if you want to add anything beyond this as well.
Yeah, Farhan, actually, I sent you like one example GitHub. I think it might also help to go through like what the fellow will see once the GitHub action checks happen. So that way they know everything is in that place. And a lot of
Yep.
this stuff, by the way, to everyone on the call, once you submit the PR, that is when these automated Git actions will essentially start working. It's similar to a Git workflow. So that runs in the background. But you should basically see the feedback from there. Um, Farhan, I sent it to you on Slack. So if you can just open that.
Yeah, I'll just
Yeah.
stop screen. Can you make me a collaborator on that? Since I was testing, I was still
Oh, yeah,
yeah,
let me
yeah.
do this. I can just share the screen. That's fine.
Okay, for sure. Yeah, that works.
Great. All right. So essentially, once you actually put in the PR, this whole set of Git actions start working, right? So what happens is most of these checks kind of run line by line. So initially, like when you look at the static checks, you will see a bunch of feedback on, hey, okay, which of these specific checks it failed. So the way it would work is once this fails, you will have to go back, fix the task, and then you submit another PR. So because it is line by line, or at least check by check, the next check, which is basically like an LLM check, which checks on different criteria, that doesn't fire until the static checks all pass. And then once your LLM checks all pass, your next pass at run doesn't get flagged, or rather, actually, first you do the Harbor Oracle and the or Harbor Nubi, and you will see whether those pass or not. And until those pass, you won't get to the next stage. And the next stage, it's not here, but essentially what happens is this is where we run the pass at, and you'll see a pass at result with like a summary of what exactly is happening. It's more of a summary of the trajectories that are created by the model once you run the pass on. And you should be able to use a lot of this information to go back and actually edit your tasks. So the idea is you will be given as much feedback within your attempt layer, so which should ideally help you iterate and make your tasks pretty much submittable, ready to deliver level, right? So that's the main idea. So that's the reason we are trying to create these loops where you get all that feedback at your attempt stage itself. um, but and outside of that, once all of this is done, that's when you'll essentially end up submitting the task on the platform. And once the task is submitted on the platform, we're still keeping some human review layers for now. So we'll likely do like a manual check as well on a lot of these tasks. And if we do get enough signal that things are looking good, then the task basically goes to RTD. But if there are still a few fixes that we do need to make, those will come back to the attempt layer to make the fixes. And once you make the fixes, you will basically go through the same process again. So yeah, I think that's one additional thing that I just wanted to add. Outside of this, I think yeah, the one thing I will flag is these are a lot of checks, and one of the reason is the expectation for the difficulty on these tasks is pretty high. So mainly given the situation that we are expecting the model to be stumped, right? So, um, but again, we also need to be very clear on the fact that the model is not stumped because of timeout issues. It's mainly stumped because the model doesn't have the capability to run. Um, so given all the context, is it such a high domain expert type of a task that the model cannot do it? That's the final goal. So that's the difficulty level. So just a heads up, you will be seeing a lot of flags. You very likely your first attempt you won't pass the task. So I would say you will probably need to be very patient with during the whole process. But our goal is to give you as much detailed, granular feedback as we can to make the task. So that's the goal. But yeah, happy to hear any other questions. I think that's mainly what I wanted to share.
Yep. Thank you so much, Ritesh. Uh, I am assuming all of you are clear with the entire workflow of Dynamo. Great.
Cool.
Um,
Awesome.
yeah.
Great. So
So,
yeah, yeah, go ahead. Just one more point I think I'll add. I know a lot of you have already started doing the assessments and submitting it. my goal is to we are trying to do a manual review for now. So I'm gonna go through a lot of those assessments, and once I start passing, hopefully within the next hour, uh, you all should start having access to the tasks. So yeah, please just um, be on the lookout. Sometime within the next hour or two, you guys should be completely onboarded if you have made sure that the rest of the checks are all passed. And yeah, we can get tasking. But yeah, Farhan, what else?
Yeah,
Anything
I,
else?
I was just I was saying that in the next 45 minutes I'll probably be making a war room as well. And our goal for today is that we all get you onboarded and started onto this project, and we are trying to get at least 10 tasks, right? So it would be great if all of you could join the war room, and then I'll be there as well. Ritesh also might be there as well. So we will be here in the war room giving you live support to make sure that you all submit a very, you know, a stellar task. Yep, I'll be making one in the next 45 minutes, so that would be around 2:30 p.m. PST.
Yeah,
So yeah,
yeah.
I look forward to seeing all of you there.
2:30 or 3 p.m., one of those. Just
Yep,
need to make sure that I'm able to send everyone through in the
yep,
meantime. But yeah, my
yep,
plan is to do that within the next hour.
definitely.
Awesome. Great. I'm not seeing any other questions. So yeah, thank you so much, everyone. Yeah, we really uh, think you guys have the capability to do this. It's going to be a challenging one, probably. Uh, yeah, I guess use your graces.
Yep, definitely. Welcome once again to Project Dynamo. We appreciate all your help over here and appreciate having you here. Let's get this done.
Sweet.
Cool.
Thank
Nice
you.
meeting you, Frank.
Yep, nice meeting you as well.